Wait. Okay, so let us start our class today. And because next week is our final project, so the time length of today's class will be won't be very long, maybe just 1 more hour. And so I think you can take more time on your final project. So today I will continue the class of the adversary attack, and then I will back to teach the secure multi-party computation. It should be taught in federated learning, but because we have no more time at that time, so I will back to teach this content today. Okay, so let us start our class. Today I want to introduce one of example of adversary attack, one pixel attack. And when you remember the definition of the adversary attack, maybe we can check our class next week. In next week, we have introduced a very basic idea for evasion attack. It is also one of the adversary attack. When we teach the adversarial attack, especially for evasion attack, we have said we can add some noise, which is very small. We can add some very small noise to a picture, and we can make the machine learning model to we can mislead machine learning model to make a wrong detection. Okay, so and in one pixel attack, we will let the noise will be very small, and the degree of the small noise should be only 1 pixel. So not only like this, we will only have 1 pixel like this. In these pictures, we will have only 1 pixel is different with the original image. You can see like this. Like this picture, we only make a difference in 1 pixel, and we can make the deep learning to make a wrong prediction of this image from birth to deer. And or like this, when we just change a pixel of this image, we can make the deep learning to make a wrong prediction from deer to airplane and others, and also you can check others like this. If we make only 1 pixel difference in this image, we can make the machine learning to make a wrong prediction from automobile to the bird. So the one pixel attack is an extreme case of adversary attack. You can only change one pixel to an image, and you can just change the output of this machine learning model. So it is very hard to defend from this kind of attack. And I think it is very interesting. So I will make a very simple introduction for this attack. And if you can you can apply this to your final project. Can you just change maybe one bit or maybe several bits of the malware, and you can change the output of the machine learning model. So you can try by yourself. So the one pixel attack is from this paper, and we have see the result. We can change only one pixel, and we can make the machine learning have a wrong prediction. So how to find such pixel? For this kind of question, how to find one or several pixels to change the result of machine learning, you can formalize this question as an optimization problem with some constraints. And you can apply the differential evolution equation to find the solution to solve this optimization problem. And if you can you can find you can not only one pixel and maybe 3 or 5 pixel, and I think it's possible for us to make this kind of attack. So if you read the paper, maybe this paper is not named as a one pixel attack, maybe a several pixel attack of few pixel attack. Maybe you will see this kind of attack in adversary attack area. And we need to explain why we can change only one pixel, and we can change the outcome from the machine learning, because in the original input layer, maybe we just change one pixel in this layer, but in as you know, the deep learning have many layers in their structure. So this noise, when they fit into the second layer, you can observe the impact area of this image. You can find this noise. So it's only one pixel in the original input, but when it go into the second layer, you can find it has a bigger impact in this image. And then go into the next layer, you can find the impact of this noise become bigger and bigger to every next layers of the deep learning. So in the final layer, if this pixel the position you choose is very good, in the final layers we may find this impact of from this one pixel will become impact a very a lot of area of this image. So this so we can know from this process, we can know why we can just change one pixel and we can change the final outcome from the machine learning, because in every layers, the impact will become bigger and bigger. So how can we avoid this kind of one pixel attack? As you know, because it's only 1 pixel, so it is hard to use the traditional skin in adversary attack to deal with it. So the most case in until now, we will use the image processing skin to deal with the 1 pixel attack. We will try to use some skin useful image to deal with this 1 pixel attack, because it's only one pixel change, so it's very hard to deal with. So it is one student's final project in past years, and I think he does very good. So I will demonstrate his result. And he also published his final project to a conference. I think this he done is very good. So I just show his result. And this student, and he tried to use the image processing skin on this 1 pixel attack, and he tried to observe image with noise and without noise. What is the difference for the image this itself? So he thinks, can we just apply some image processing skin on this image, like we can smoothing the maybe we can apply the smoothing skin on this image. He thinks if we can smooth this impact of this if we can smoothing every pixels, maybe we can let the result of every pixel's impact, maybe we can change, maybe we can smooth it. So in by this way, he tried to construct a different map. And this name is just named by him. He has no art. He just want to say, he want to find every he just want to find the difference among every pixels, like this pixel and this pixel, what is the difference, and this pixel and this pixel, what is the difference in their RGB values, what is the difference. So he want to measure the difference in every pairs of pixels. So by this way, he can construct a difference map of an image, and by this way, he thinks he can try to deal with this kind of 1 pixel attack in adversary attack. In 1 pixel attack, maybe only 1 pixel is changed in original image. So he thinks maybe he can find a difference in every pixel. And this student thinks he thinks the for the 1 pixel attack, it seems it will be a 1 pixel is it should be have a very difference with neighbor its neighbor's pixels. So he find maybe we can just measure the difference with every pairs of pixels. So by this way, it just use measure difference in every pairs of pixels. Yeah, so by this way, he construct a difference map like this, and he measure a difference in every pixels, and he check all the neighbors of every pixels, and he just propose an equation of the difference. He just define the difference by himself. He just thinks if the difference bigger than some threshold like this in RGB values, become if a difference, if the difference with one pixel and another pixel is bigger than one threshold in RGB, like larger than the 115, and he's 150, and he will think it should be calculate it as 1 degree. It will at least it will add one more degree in these pixels. So every pixel will this kind of degree value in every pixels. So, and he also will calculate the average in every degrees, because he thinks he need to divide by the neighbors, because in the pixels in the edge, they should have no more it will have a fewer number of neighbors compare with the other pixel in the center position. So he want to deal with the pixel in the edges. So he will do divide by the n neighbors, and he also want to keep this degree should be smaller, so he can make easier color lane. So he will let the n value multiply by 10. So this is the equation proposed by this student. So by this way, he can calculate every difference results for every pixels, and he can draw these results like this. So by this way, you can find it since there in original one pixel attack this one pixel, it should be have a bigger difference with the other neighborhoods, with the other neighbors pixels like this. And he also want to make some smoothing results, so he also construct an average map, and it is very easy. Just average. If these pixels, it will calculate its average results from each and its neighbors like this. It will make an average from every pixels like this. And in his thought, because he observed, if we consider a pixel with high degree like this, with high degree, it may have something strange here, because the result he wants is try to propose a smoothing scheme for the original image, and he don't know which pixel is just the result of one pixel attack. So he want to make a smoothing smooth image, and he thinks if he just calculate the average in every pixels, and without consider with a high degree, and the result will become like this. It will be a little strange for the original image, and it may be have some remaining impact results from the 1 pixel attack. So by this way, he just add a if condition. We only consider the pixels without a high degree. The high degree means like this. This will have a very big difference with the neighbor pixels. We don't consider this kind of pixel in our averaging result. So by this way, we can make a smoothing skin on original image, and we can avoid the impact of this kind of 1 pixel attacks its objects pixels like this. So this is his result. By this way, if we can apply he proposed smoothing skin, we can let the original image from this to this. You will get a smooth image, and by this way, he proved this can have a very good result in his experiments. He can avoid the adversary attack. Okay, so he also tried to measure the number of the data set on each class, and he also found maybe if it is 10 class in one data set, it seems for these results it can have a better experimental results like this. Okay, so this is a very simple demonstration of PACE students' final project, but it is not applied for our final project because our final project is mainly for the malware experiment. So you need to keep the functions of the original malware. So this is a little difference because in his final project, he don't need to care about the malware and its function. It's just an image. So I think there is a little difference. Okay, so I just demonstrate these results of a PACE student. Okay, so okay.
Would it be possible to postpone our final project presentation by 1 week? Because it's now next Monday, right? So we have a very short time, and then and I think it's not really because we changed our topic last Monday, and then this means we have only 2 weeks to complete, including this week, right? So I think it's not feasible because I tried it, but it's every time I change it, the malware it gives us the 5 corruption errors. So I think we need more time.
Okay.
Possible malware.
For other students, yeah, there is one student proposed this suggestion for other students. If we yes, or how the other students thinks about it. Should we just have a final project next week, or yeah. But by this way, because our next week is because in this semester the next week is the last week of this semester. So by this way, we cannot, because some students they may need to come back their countries because I remember our school hold suggest this plan of the semester is he want to care some students they may want to come back their countries to have the Christmas days. So if we just delayed 1 week, maybe these students they cannot on their schedule to come back their countries. Yeah, because you think in the days after next week it should be very near to Christmas days. So I guess okay. What?
On Friday.
Friday? But we have no class. No class. We have no class. Or you can just accept just uploading the video to us, and we just. Maybe you if we want to delay the final project, maybe.
Students who are in abroad.
Just upload the video, but because we have no the physical classroom in other time, even after the semester, we have no the physical classroom.
Oh.
Yeah, so there have some issue we need to care. If we accept this idea, maybe we may just upload a video, and because we have no physical classroom, and I think it is a little hard for some students. They may if we just delayed 1 week, I think it may be harder. It's harder for some students if they want to come back to their countries. So I think another way is just to upload the video. Yeah, if we want choose another time for the final project. So maybe you can think what kind of plan we can do.
I will try my best.
Yeah,
I think
I know.
It seems like other students are quiet.
Yeah,
because
I know.
They can finish, right?
Okay, so by this way, let me think the next week. Next week is this. The Christmas is it's very close to the Christmas day. Okay, so let me think. Yeah, we can. If it is truly hard for students, we can let the student just upload the video, but we can delay it to the next week. You say maybe we allow the student upload their video before the Friday. Before the Friday. Oh.
It's a fair percent. Never mind. I'm finished.
As I know, yeah, there are also some students is truly they worry about the time is not enough. So.
I really want to make it read like can be passed through the system, because as our current accuracy for malware detection is lower than the 0.6 60%, then it's easily passed. So first our target should be increase our accuracy for the detection above maybe 0.90%. Then we can show ours is now we can pass through the system. Otherwise, lower accuracy, then we can easily, without thinking too much, we can easily pass, right?
Yeah.
So that's why the reason is we need to some time to increase our current model, because we are using federated learning. And that's why I just consider on that point. But yeah, but if it's okay for other students,
Yeah, can we ask other students? Should we change to the format of the final project. We just upload the video, and we can have more time. Maybe in before next Friday, you upload the video, and yeah, it should be. So how do you think about it? Can we maybe, if you think it is okay for you, maybe you can raise your hand. You will just delay the time to the next Friday. Okay. Okay. So yeah, I think maybe the next Friday is okay, because we cannot delay 1 week because it's very close to the Christmas Day. I think it is not okay for some students. Okay, so maybe the deadline become the next Friday, and but by this way, we just the student just upload the video to the Moodle. Yeah, maybe.
We can do it online, right, Professor? If you don't have the classroom.
Oh, no, so I think it's very hard because we have many students in this class. We have 81 students, so we cannot care about every student if they have class in next Friday. I think it's very hard. Yeah, but if we just upload the video, I think it should be. I think it should be okay for all the students. We don't care about they have class or not. Yeah. Yeah, so it's okay or not? Okay. We just delay the deadline to the next Friday, and we just upload the video. Yeah. Okay, so yeah, and I think it should be the next Friday and not this next Monday, because it's very too close with the Christmas days. Yeah, so I think maybe the deadline is okay here is okay, and it's just a deadline, and you can upload your video in any time before the deadline. Yeah, you can upload your video in Monday or Tuesday or Wednesday, and not the deadline. You can just upload your video before the deadline. It's okay. Yeah. Okay. So, yeah. Okay. So, have other suggestion? Any other suggestion? No. Okay.
Professor, is it end of Friday or is it beginning of Friday? Because times is not really
Okay.
just consider because
The end of the Friday. The end of Friday. Yeah. Before the midnight. Yeah. Okay. It's okay. Yeah. The end of the Friday. And I hope you can, you should not late to the last minutes. I assume it's very, I think I worry you cannot complete it before daylight, so you can do it as early as possible. Yeah. Okay. So the deadline is the end of the next Friday. Yeah. Okay. So if you want to come back your countries, I think you should complete it as early as possible. Yeah. Because I don't know the flight of you. Yeah. I don't know your flight information. Yeah. Okay. Okay. So no other question? Okay. If no other question, we will continue our teaching. And I have said, because I think because next week is a final project, so I will not teach. Too much today. I will just finish the adversary attack, and I will be back to the secure multi computation. I have I have something. I have some content have not introduced, and I think maybe I can introduce in this final class. I think it's a very simple example, but I think it's very basic, and you should note for this idea. There is area is called secure multi-party computation, and what is related to our class. When we back to the federated learning, we have no. There is one more. There is one kind of federated learning is there is no server, no central server in there is no central server here. Oh, like this. When we introduce the federated learning, I said in most cases we should have a central server, and it should be a efficient solution for most cases in federated learning, because if you have a central server, this server can help you coordinate all the kinds. But we must say, in some real world case, we may not hope there is a central server, and we just have several clients. And how can we run the secure multi-party computation in this kind of situation? If we don't want a central server among these clients, how can we successfully run the secure multi-computation? Like if we want to get the sum of the gradient of from these clients, how can we get the sum from this client, and in a secure way? How can we do it? So I think it's a very basic. I think it's very basic idea I should introduce. So I think I still teach it now. In this kind of case, if we have several clients and we want to get a sum of the gradient in federated learning, or we just want to get a sum from these clients, and maybe these clients for this value maybe not just a gradient number, and maybe it's just the money owned by this person. Like maybe the first person has $3 million, and the second one is have $7 million, and the next one have $1 million. And for this person, they don't hope the others person know his number or his money, what is it. So how can we get a sum? How can we get the sum from this number of the different kinds? And we can we don't disclose the numbers to each others. How can we do it? So there are many methods can do it, and I just introduce a more basic method in this area. In this basic idea is we can randomly select one person or one client in these kinds. Maybe we randomly select only one client or one person, and then this kind he generate a random number, by himself. And this random number is a secret, and he can let the others know these random numbers content. And then this client he ate the his own number. In this case is 3. He ate the 3 with this random number. In this case is 100. He ate the 3 and with the 100, and then send the sum value to the next client. And the next client, when he receives this value, he cannot know the true content of the previous client. He don't know the value 3 because he just get the sum result from the previous client, and he don't know the value of the random number. He don't know what the random number is, so he cannot easier guessing the true value on by the previous client. He don't know it is 3. He don't know this value, and then this client he just add this value from previous client with his own number, and then send a sum result to the next client. And the next client, he also have no idea of the values owned by the previous 2 clients, because for the sum value he received is the result combined from the random number and the numbers owned by the 2 clients. So for this client, he have no idea for what the value owned by the previous 2 clients. Let's finish this page, and I can let this today's class maybe have a early finish. Okay, so this guy he would have no idea of the true content of previous 2 clients, because the random numbers and he don't know the combination of the 2 values. And then he also add the value with his own number, and then send the sum to the next client. And the next client would have no idea for the true content of the previous 3 clients. And then every client do the same, they repeat the same action on these values. And then the last client, he sent the sum value back to the first client. And the first client, because the random number is generated by himself, so he know what the random number is. So he can just subtract by this random number. So finally, he can get the sum of all the clients. And in this process, all the clients, they don't know each other's values. So this is a very simple secure multi-computation. But yeah, he don't know. We can get a sum and in a secure way. But we should have an assumption in this protocol. We will say this is a kind of the protocol, a kind of the communication method. In this protocol, it needs some assumption. The first is require at least three parties. Require at least 3 clients involving in this protocol, because if there is only two clients in this protocol, you can see when if only 2 clients in this protocol, when the first client he add with 1 random number to the seconds, and the seconds he gets the result and he add with his own numbers and return the sum to the first client, and the first client can just subtract by the random number, and he can know the true value owned by the next client. So this protocol is require at least 3 clients in this protocol, because if we can have 3 clients, you can see the second client, they will add the random sum with his own number, and then send to the third client, and the third client will return to the sum value return to the first client, and by this way the first client cannot know what the true value owned by the 2 clients, because the results combine the 2 values, the 7 and 1. So not only the random number, and he just have a combination of the 2 values in the final sum. So by this way, if we can have at least 3 clients in this protocol, we can assume guarantee this protocol is secure. And the second assumption is we need to assume these parties they don't collude with each others, because if one in this process, if one client, for example, the first client, if the first client collude with the third client, they can induce the true value of the second client, because the third client, they can it can compare the result he received, and he asks the question the first client, and the first client can will say the sum value sent by himself is 103, and the sum value you receive is 110. So by the observation, we can induce the value owned by the second client should be 7. We can compare 2 values. So in this protocol, there is 2 assumptions. At least 3 parties, at least 3 clients in this protocol, and these clients, they can not collude with each other. And if you can guarantee the assumption, and we can say this protocol is a secure multi-party computation, we can get a sum value of from these clients, and we will not disclose the numbers to each others. So it's a very basic introduction for this area, and you can observe many different versions of this kind of idea. Maybe they will apply the homomorphic encryption in this process. Maybe they will encrypt this value and then send to the second client, and by this way you can you may not need the assumption. Maybe you may not need the second assumption. These parties they don't collude. Maybe you by the homomorphic encryption, you can have a fewer assumption in this protocol. Or by this way, there are many variations from this basic idea. Okay, so I think because it is next week in teaching, and in the next week is a final project. So today's class I just finish here, and you can come back to continue your final project. So it's okay. Okay. So have any question?
So next Monday we don't have any class and just upload our.
Yeah. Yes. Just upload. Yeah. Remember in the end of the next Friday. Okay. And I will provide the link. You should upload the video to the Moodle website. Okay. Okay. So any other question? Okay. So if there is no other question, let us stop here. Okay. So this is the end of our today's class.